Hello, everyone. Welcome to another exciting CAD to part demo in 30 minutes or less. While we let others join in, be good to give some introductions. My name is Tyler, and I'm the head of digital marketing for Nexa 3D. And today I'm joined by Mackenzie, who is our very talented head of applications engineering. Say hi, Mackenzie.
Hi.
And with Mackenzie is Eduardo. He's a mechanical engineer at Nexa 3D. So before we dive in, we just want to give a big shout out to all of you for rolling with the punches and being so flexible about the reschedule for this demo. And we're excited to be here today because for the first time live, we're taking a dental model from CAD to design to print to post-processing, including wash and cure in well under 30 minutes. This really changes the landscape of what's possible in digital dentistry, and you'll be able to see it in real time. We're also going to send you a recording of this demo later today, so you can watch it over and over again or share it with your colleagues. Finally, we want to thank all of our dental channel resellers for supporting us today. And we also want to extend a big welcome to our two new dental partners, Harris Discount Dental Supply and CAD Ray. So before I hand it over to Mackenzie, if you have any questions you'd like answered by our team during the demo, be sure to drop them into the Q&A session below. And with that, we can get started with the demo.
Awesome. Thank you, Tyler.
Yeah.
Just so you guys are able to hear me a little bit better, I'm going to plug in my headphones. Give me 1 second. Okay. And to get things started, we're going to go ahead and start the print really quickly, and then I'll give an intro into the software and what we're actually printing. So as you can see, Eduardo is going to go ahead and start the print. Nice. So what we are printing today is 10 dental models in less than 30 minutes. So this print is actually 13 minutes. So let me go ahead and share my screen so you can see what we're working with today. Cool. So this is Nexa X. This is our proprietary software that we use to prepare and slice our print files. So as you see here, this is what we're printing today. We have 10 orthodontic models. This is an approximate print time that you see here where it says 17 minutes. In reality, this is more like 13 minutes, and it's going to give you a more accurate print time once you actually slice your models. So when you open up Nexa X, this is what you see. It's going to be your intro menu. So you're going to want to go ahead and select your printer. In this case, we're printing with Zip in our Extent 201 gray resin. This is one of our fastest dental model resins. And it's validated for 50 and 100 micron layer height. For today, we are printing at 100 micron layer height. For the basic version of Nexa X, not the Pro version, what you see here is basically everything that you're going to have access to. So with that, as I mentioned, you're going to have your printers, so you can go ahead and select Zip, along with all of the different resins that we have pre-validated. You're going to be able to select your layer height, and then also have some access to some initial settings for the print. So with that, you're going to have your base layer settings, wait time, and then your base and top exposure. Something that is extremely useful for dental applications specifically is having access to this base edge offset. So some of you are probably familiar with elephant's foot, which can happen due to an increased base exposure for the base layers, and you're able to compensate for that using these sliders here. So once you're happy with all of your settings, you can go ahead and click apply. All of our pre-validated materials have been validated with print settings and support settings. So once you select your material, it's going to go ahead and auto-populate both your print and support settings for that specific material on that specific printer at that specific layer height. So once you're here, you can go ahead and import your models. I've already imported the scene of what we're printing today just so that I can show it to you. But you are able to import either an STL, OBJ, or 3MF file type. In addition to that, you can import previously saved scenes. So that's what I did here. So this is something that I'd already pre-prepared, and I can go back in, re-import it, and edit it. You can also import your NXA, which is the build file. You do have access to some basic translational features here. Orient to base is specifically useful for dental models when you're printing directly on the build platform. That ensures that the base is going to be in contact with the base of the plate, as you can see here. In addition to that, you also have some basic translation, rotation, scaling that you can do freehand here using these tools, or you can also do via typing in numerical inputs here. Support settings are also super helpful, especially when you're printing removable dies or other types of dental models. So for these, I tend to print directly on the build platform, so I don't need supports. And that only works when you have a flat surface. But if you, let's say you didn't have that, you would want to be printing on supports. We have two different types of supports. We have both pillar and scaffold supports. And each of these comes with pre-validated settings, like I previously mentioned. You do have access to all of these settings, so you can modify them as you wish for both scaffold and then also pillar, as you can see here. In addition to that, there's also options to add cones, which is useful if you're printing certain models. Another feature, this is only available with the Pro version of the software, is repairing dental models or other types of models, in addition to mesh editing tools such as hollowing, perforation, and latticing. And then here you also have an auto nesting feature. So this is useful for dental models. As for this scene, I oriented these myself. However, auto nesting could have been super useful in something like this. In addition to that, you also have the option to duplicate out your models, as you can see here. So duplication array, if you have one model that you want to print multiple times in the same orientation. In addition to that, something that's really useful is measuring tools. So this is helpful if you have hollow models. You can measure the wall thickness of the parts. And then let's say I am happy with my print that I've set up here. My next step would be going ahead and saving my file. So I would go ahead and save this. And what that's going to do is it's going to save the scene file, like I previously mentioned, and then also create the build file, which is then submitted to the zip. I can send this directly to the zip via Wi-Fi or Ethernet, or you can also use USB. Another method that you can do in order to start or prepare your builds, this is one workflow that is more manual. We also have a more automated workflow using what we call DentFlow. So DentFlow is using this little icon down here. I'm going to go ahead and select yes. And then once I'm brought into here, it's going to kind of walk me through every single step that I just talked to you about in terms of orientation, supports, that type of thing. So I'm going to go ahead and add a category. Today we're printing orthodontic models, so I'm going to select that. I'm going to add some models, so I'm just going to select a few models here, and then it's going to import those. Nice. And what it's doing here is it's also going to be checking whether the model needs to be repaired. So if the model needs to be repaired, it's going to show up in red right here. This is typically due if there are overlapping triangles, flip normals, or a non-manifold mesh. So if that's the case, you're going to want to select repair right here. These are the different steps of DentFlow. You can enable or disable all of them depending on what you're looking for. So I'm going to make sure that repair is turned on for this because I do see some models that are showing up in red. In addition to that, I'm going to make sure I'm on the zip. And then what we're printing with today is extent 201. So just to keep it in the same vein, I'll select that as well. In addition to that, you also have further settings here. So you have, if you had like previously saved print profiles, they would show up here that you could select. In addition to different layer heights, all of the enablement features that you see here are also here as well. However, in addition to the auto orient one, for these ones, I want them to be oriented flat, so directly along the build platform. However, in some cases, it is useful to print orthodontic models vertically. If that's the case, you can also select vertical and or angled. When you select angled, you can put in actual value as well. So I'm going to go ahead and click apply. And then I'm just going to duplicate a few of these out for auto nesting purposes. Cool. So once I'm happy here, I'm going to go ahead and click prepare models and review. And this is going to bring me into the next step. So the first thing that it's going to do is repairing the models. So as you can see here, this model that was at the top of the list initially showed up in red. However, it's been repaired, so you can see that that's no longer the case. And what it's also doing in this step, it's going to be repairing the models, and then it's going to auto orient the models by category. So we are only doing orthodontic models in this example. However, let's say I also wanted to do some other types of models, such as like removable dies. That would be in a different category, and then it would do it all at once in this step as well. So as you can see here, it's going to be showing me a preview of after orienting all of the models. In addition to that, there are some cool features that are specific to DentFlow that are useful for dental models. So you have your orientation that I mentioned before in the other menu as well, including orient to base. You also have the option to add supports here or modify supports. And then something that is specific to DentFlow is you have the option to plane cut your models and or do a base extrusion. So I'm going to show you on this one, we're going to extrude the base. This is helpful if you have any thinner sections along the base of your model that might make it more difficult to remove from the plate, or you just want to make your model a little bit more stable. So for this, I'm going to add approximately 1.2 millimeters to the base, and then it's going to go ahead and extrude along that base profile, as you can see here. So now it is thicker. Another option to do is a plane cut, so I'll show you that on another model. Let's go to this one here, and I'm going to add a plane cut. So maybe I want to reduce my print time. So your print time is determined by the height of your print. If I want to speed up my print and my model allows me to do so, you can remove some of the base, and that allows you to print faster. So as you can see here, it chopped off that base. So now that I'm happy with this, I'm going to return to my grid view. Going to look at these models. They're all oriented flat on the build platform, so that's what I'm happy with. And then now I'm going to click Prepare Builds. So when I select that, it's going to go ahead and bring me back into the previous interface that I showed you before in terms of the manual workflow. However, now it's going to be nesting the models. So what it's going to do is it's going to determine how many models can I fit on one build platform, and if there's still more models left over, it's going to bring that out into multiple scenes, as you see here. So this is saying I can only fit this many on this plate. So I'm going to do it in 2 prints instead of 1. So I'm going to go ahead and apply this. I'm happy with this. And as you can see here, it's nested this one and then also this one as well. You do have the option to still modify all of the models here. However, if you're happy with everything that happened with the DentFlow interface, you can go ahead and click Save as you were previously doing. Cool. So I'm going to go ahead and stop sharing my screen now so we can talk a little bit more about the zip itself. Cool. So we have 4 minutes left on our print. So for the zip, it's our desktop resin 3D printer. We're currently printing with Extent 201, which is one of our fastest orthodontic model resin materials. And we're printing at 100 microns, like I previously mentioned. With the zip, it's 4K resolution with 52 micron pixel size. So it's extremely fine resolution. And you can print anywhere from 25 to 200 micron layer height. Majority of our materials, depending on the application, are validated anywhere between 50 to 200 micron layer height. In addition to that, it has a removable vat with electromagnets. So I'm going to have Eduardo show you that right now. So as you can see here, the electromagnets are on the back. So that's what kind of locks into place with the zip itself. Once it locks in, you can go ahead and print. You can put resin into this vat directly. And then let's say you want to switch out your materials. You're printing with multiple materials. Instead of having to drain the resin from the vat every single time, you can pull the entire vat, since the membrane is attached to it, out of the printer and put another one in. So you're able to store resin within the vat for anywhere from 2 to 3 months. So that's extremely helpful if it's in a cool and covered environment. So that's extremely helpful if you're looking to print with multiple materials. As he was showing you, the membrane is connected via 4 clamps along the base. So you could hold that up for a second. Thank you. So as you see here, the vat itself is metal. However, this blue frame right here is the membrane. So the membrane's attached via these 4 clamps here. So let's say you do want to switch out your membrane. It's easy to just pull one off and then put another one on very quickly. It's not screwed on or anything like that. In addition to that, you have these 2 things right here. So this is where your resin's going to be flowing in if you're using the cartridge system. There's going to be a spout that clamps onto here, and then your resin cartridge can set in here, and it's going to go ahead and fill the vat with resin. And then you're going to have a level sensor over here that's going to be monitoring that level as well. In addition to that, you also have a pour spout right here. So let's say you do need to drain your vat for whatever reason. We make it a little bit easier for you with having this pour spout. So you can either use a syringe or you can pour it directly back into the container, making sure that you're using a filter with that as well. Thanks, Eduardo. And then the cartridge itself is right here. As you can see, we have some printed accessories that we made with it. So as you can see, this is the lid for the cartridge. So what you're going to go ahead and do if you wanted to use it is you can just open this top part and then set it directly into the printer. If you wanted to refill it, let's say you're printing with a custom material, because our printers are open platform. So you do have the option, if you would like to print with the material that we have not pre-validated. With that, our printers operate at 405 nanometer wavelength. So you want to make sure that your material is validated for that. But let's say you do, we do also sell these cartridges empty for custom materials. You're able to unscrew the entire top and fill and refill the cartridge as well. Thank you. And then it looks like our print is finishing up right now. It's on the last 3 layers. So then I'm going to have Eduardo pull it out to show you, and then we'll continue along with the rest of the post-processing. Just getting ready with the tray. You want to make sure you have trays handy just to help with any type of drippage or mess that could occur along the way. So it's going to be lifting up now. And then the next step that he's going to be doing is going to be washing the parts. For this, we're going to be using what is back here. So I'll move to show you that in a second, which is our zip wash and cure. So it's a wash and cure unit in one. For this workflow and webinar, we're going to just be using it for the wash features. So we can also show you our new X-Cure desktop as well. So he's going to go ahead and pull out the parts right here and then show them to you guys so you can see. Looks similar to what I just showed you in the software. We printed 10 orthodontic models in 13 minutes. Thank you. And then he's going to go ahead and go off screen for a second so that he can remove the models from the build platform and then get ready to wash them. So in our wash unit today, as you'll see when he lifts up this black lid, let me lower this so you can see it a little bit better. So we currently have IPA, isopropyl alcohol, within the container here. However, you can also use our own solvent called X-Clean. So within the, he's going to plop those in, and then we're going to wash them for 2 minutes. We have pre-validated post-processing workflows for all of our resins that we have validated. That includes wash time and then also a post-cure time. So he's just going to make sure it's on wash. It's at 2 minutes. He's going to click OK. And then I'm going to have him show you the container that's a little bit cleaner down below just for demonstration purposes. So as you see here, this is the container that you would be keeping your solvent in. It has a lid, which is useful for any type of fumes you might experience with the solvent. In addition to that, you have different types of containers or wireframes within there so that you can wash your parts either directly on the build platform if you're looking to do that, or remove them from the build plate and have loose parts. So that's what we did, is we removed the parts from the build platform and then are washing them in this wire cage. So what's going to happen is, as you can probably see in back here, is the solvent is getting agitated via magnetic spinners. So that is what is occurring there. And then once that's done, we're going to go ahead and put the parts in the X-Cure desktop. So the X-Cure desktop is one of our new post-processing units that we just came out with. It works at 3 different wavelengths, so you can either choose 1, 2, or all 3 at 365, 385, and 405 nanometer wavelength. In addition to that, you have varying levels of power. So that's useful to really fine-tune your post-processing workflow and give you more options along the way. You can also save up to 8 different pre-validated settings that you have set. And it has a nice digital interface on the top with a touch screen. Cool. So we have 20 seconds left. And then I'm gonna have Eduardo quickly dry the parts and then place them in the Xcure desktop. So this desktop unit is extremely fast and brings down our post-processing time by up to 80%. So typically, let's say you were going to post-cure the parts in the wash and cure unit, which as I mentioned is also a cure unit. That would take about 30 minutes to post-process or just post-cure your parts alone. However, with the new Xcure desktop, we're able to post-cure those parts in 5 minutes. So with that, it's extremely fast and allows us to do webinars like this instead of having to, you're able to print parts extremely fast, but then your post-cure takes longer than it takes to print. So we wanted to make sure that speed was in every single step of the post-processing workflow. So he's going to go ahead and dry off the parts and then open up the lid of the Xcure desktop as you see there and place the parts in. Another cool feature with the Xcure desktop is that you have a one-way mirror. So you're able to see from the top what is going on in the Xcure desktop. It's going to be rotating as it does so. And then so it's a nice observational window. So he's going to go ahead and select the time. As I mentioned, it's 5 minutes and then click OK. Cool. So I was thinking now we could open it up to any questions since we're just in the post-cure time now. Looks like we have 2 questions. What micron are you printing at? We're currently printing at 100 micron layer height, which we like to use for orthodontic models for the speed aspects of it. However, you can also print with this material at 50 micron layer height if you're looking to get finer resolution or surface finish. For which dental applications are you printing these models? So for this dental we're using orthodontic models for this dental application. Awesome.
I have a couple questions that came in. And we don't want to address. How do you address issues like warping or distortion during the printing process, particularly for larger and more complex dental models?
Yeah, that's a great question, Tyler. In order to print like more models that might be susceptible to warping, there are a few considerations that I would use with the post-processing workflow themselves. So one thing is printing the models directly on the build platform to allow greater adhesion, and then warping can also occur in the post-processing aspects of the print. So what I would recommend doing is washing and post-curing the models directly on the build platform to help mitigate any type of warping that can occur during the post-cure step. If you do this, then I also recommend doing an additional second post-cure after you remove the models from the build platform after the first one in order to ensure that all surfaces of the model have been post-cured to improve dimensional stability over time.
Nice. Another one we got was, what are the best ways to orient models on a build plate for the fastest results?
Yeah, so as I mentioned, your print time is based on the height of your print. So the shorter or lower height of your print, the faster it's going to be. So with that, the fastest way is going to print models flat directly on the build platform. A question that came in, is the post-processing absolutely necessary? So the post-processing is necessary. When you remove the models from the printer, there's still going to be uncured resin on the outside of the parts, which you're going to want to remove since that is liquid and pretty sticky. So that's where the washing comes in, which is necessary. And then after that, post-curing is also necessary in order to achieve dimensional stability of the parts. The post-cure time for X model 15 black. So that really depends on the post-cure unit that you're using. I believe for the X-cure, our largest post-curing unit, it's going to be 30 minutes. For the X-cure desktop, it's probably going to be closer to 10.
Great.
Cool.
Any other questions you like us to answer? Emails coming in. Cool. All right. Well, we're going to wrap it up. We'll send out a recording of this demonstration later today. That way you can watch again and send it around. And with that, we want to thank you again for joining us, and we hope that you have a great rest of your day.
Thank you.